right. So to get started, I'd like to introduce you to Andrew Pikul as our guest speaker. Hey, Andrew. Um, Andrew is the principal engineer and founder of GeoPozo, a visualization framework for geological wells. He's studying electrical engineering. His background started at university nano lab working on memory store materials, and from there he built operating system and drivers, and now he focuses on Python for his own startup.
Yeah.
The goal of GeoPozo is to enable data science innovation by connecting new technologies like AI with traditional analysis environments. So, in today's session, we'll be highlighting Andrew and how his experience in operating system development influences his business.
Yeah.
Andrew will share the following topics in our conversations, things like how the industry can benefit from open source geological software, why he chose Plotly for GeoPozo, and how to create and manage a startup life. Andrew,
Mm.
how are you?
I'm good. How are you, Adam?
I'm good. Thank you very much for joining us.
Yeah, no problem. Thank you for having me.
So, to get started, can you just share a little bit about yourself? Like from university, what did you study, and then how did it move forward?
Yeah, so this has been such a long journey in my career. I mean, I'm 38 now, or I'm about to turn 38. The reason I got into engineering was actually because I was working in a hospital and I met an engineer there and they were really important in the hospital and they helped a lot. And I said, this was like, 20 years ago. And I said like, well, this is really what I want to do. I want to do something really that matters. So I went to university and I went to study electrical engineering. And then I started working in a nanotechnology lab where I was working on semiconductors and I was working on memristor materials called chalcogenides, which are a type of glass. They were used in making DVDs and making CDs. That's the material they used to make
Oh,
those. But then they were looking at how they can combine those materials with silicon for inside of memory chips. I did that for a while, and then I started freelancing on circuit design and board design. And I did a bunch of stuff in there. I worked on LCD screens, I worked on pool equipment, I did a bunch of toys, I did a lot of IoT stuff, and that lasted for 4 or 5 years. But what happened was is I kept on kind of getting sucked into software because all of those things also have software needs. And I had to already do a lot of work on embedded software, C, and operating system design because I was working on embedded technology. And eventually I found that it was just easier to get a job and to make money in just pure software. So I ended up working on backends and Golang for an agency. And that's where I spent like a couple years. And then I took a break. And when I decided to get back into the industry, I met Steven and we decided to start working on these Python solutions for geologists because we felt like there was a really big gap in the open source solutions, specifically for geologists and this sort of type of geological analysis. And it just took too long to get stuff done. You have all these tools and stuff coming out for AI in Python. You have a lot of data analysis tools in Python, but you still need the sort of fundamental visualization software that geologists use. This is like the language of their science. And I wanted to make a way to connect to those things. So I started working on the open source GeoPozo.
so I want to get back to that actually. That's a very interesting topic. How you having encountered or meeting Stephen has shaped your future, the startup. But before that, so you're working a lot on hardware, and then
Yeah,
that led you slowly to more and more to work on software, and that's where you learn
yeah.
different programming languages. What like if you had to choose now, like you can't do your startup anymore, you had to choose. You're going back to do hardware work or software work. What do you prefer?
Oh gosh. Software work is always going to have a better market, and it has a better market inside the United States. So just from a business perspective, it's always going to be better to choose software work. You really have to, if you want to do hardware, you really have to find a niche. You really have to find a product that's going to sell. You're making something physical, so people will buy it for a while and then it will end. You may not be able to do like the sort of monthly service or maintenance requirements. Yeah, so from a business perspective, always software. That to be said, there is something gratifying, if not much more difficult, about producing something physical.
Yeah,
Yeah,
I would imagine
yeah,
that.
yeah,
Okay,
for sure.
so you slowly moved into the software world. You learned Golang.
Right.
What made you learn Python?
Yeah. So, well, I had to get into Python Golang sort of sits in between C and Python as far as complexity, and like people talk about low level, high level, and I know this is sort of like a controversial opinion because a lot of people have an opinion about what is low level, what is high level, but generally like C, where you're writing operating systems, and then Golang is a bit more of a systems language. It's used in a lot of networking, but it has a lot of the same tools that Python has in some cases. And then I'm getting into data science, and I want to do something that I come from kind of a science background with the technology, so I'm interested in this geology stuff because there's charts and there's graphs and there's science involved, and I want to do that because I like science. And Python is like still, it was then, it is now. What do we call that? The language franca,
Yeah.
or like it is the language to use for data science. So I got into Python, and it wasn't with all my other experience in other languages. It really wasn't that difficult for me.
Was it self-taught?
Python is completely self-taught. Yeah, actually, almost all of my programming experience is completely self-taught. I started when I was like 13. I picked up my first C++ book and started reading. So I actually found it recently when I was cleaning. I found my original like C++ book, and I have like an early edition of some of the like oh, I forget their names. That like the people who designed C. I have their first books and stuff.
Wow.
So yeah,
That's cool. All right, and obviously we're going to talk today about your startup, which is an
yeah,
independent business. Obviously, did
yes.
you even before the startup, which a lot of our viewers are always interested in when we bring this up in Hangouts, did you have your own independent business before the startup?
I had tried to do a startup before in hardware, like probably over a decade ago, and I put together like a very small team. I mean, I was freelancing before that, so yeah, that was my own business. I mean, that required me to negotiate all my contracts. The first year was really difficult because I did not know how to negotiate, and something as simple as people asking for changes of scope inside of a
Mhm.
contract, I didn't know to push back on that, and I didn't, and I ended up really just getting driven all over the place,
Yeah.
having to do tons of work for the same price. So after the first year, I unfortunately learned all that, or fortunately, who knows, learned all that the hard way. And I learned how to qualify my clients. I learned how to talk to my clients. I learned how to like set contract terms, which I had to do if I didn't want to spend 16 hours a day working.
Okay.
And yeah, so there was, yeah, freelancing definitely helped me on some ends, but it's very difficult. I mean, this is truly not like much better to go find a mentor inside of a company. Way
Did
better to
you
do
did you
that.
go through any burnout?
Yeah, I definitely, so once I started getting into software, that kind of was my burnout because hardware is so hard. Because I mean,
Oh,
when you produce hardware, your iterations are more expensive. And it's so much easier to spend a lot of money than it is with software because you have to get things manufactured and there can be 4, 5, 6, 7 week turnaround times, right? So you're just on a
okay.
completely different scale. Things can fail completely, and it's hard to reuse intellectual property. So I kind of like was like just really like heading towards software. I was like, wow, I can just recompile every day,
Okay.
and I don't have to worry about a 6 week turnaround time on my design. And if it doesn't work, I just compile it again.
Yeah.
And yeah, so that was like I was kind of like not interested in really like trying to go into hardware unless there was a really good idea
Okay.
that was really obvious. Yeah, so that was kind of like my burnout. And then I took a sabbatical like many years later, and I wanted to learn a second language, so I went down to Colombia and yeah, started working on my Spanish again.
But even before that, Andrew, so you said that about 10 years ago you had your first startup. What was that in?
Oh yeah, that was in hardware. Unfortunately, we
Okay.
were making software for hardware. It was automated test board design. So like just in software, you need unit tests. When you're producing hardware, you also need to produce other hardware that attaches to that hardware and tests it.
Okay.
And you get into the situation where it's like you've just spent hundreds of thousands of dollars and months producing just the prototype of whatever you want, and you want to take it to manufacturing, and you're not going to get quality assurance unless you go through an entirely new design iteration to come out with this test stuff, right? You need to do
Okay.
testing, right? And it's like this hidden massive cost. So I was like, I think we can automate some parts of that, but I was too young. I didn't get any funding for it. I worked on it with a small team for like a few months. We didn't get any funding for it. People were scared of it. We should have been scared of it, more scared of it than we were because it was such a big project and it was so risky and it was like, is our, huge development, is anyone going to like this? And I just went to work. I just, shut down the project and I went to work. So,
Okay. Cool. And then how many years ago did you actually go down to Colombia?
oof, that was during the pandemic. So where are we? 2021?
Yeah. Well, the pandemic started in March of 2020.
In 2020, yeah. So it would have been like a couple months after that. So yeah, at the end of 2020, at the beginning of 2021. I don't remember exactly, but I do
And
remember it was
and
they
that's
had
what you.
just they were just about to lift quarantine there.
Okay, okay. Yeah, it was pretty bad in South America as well at a certain point. Is that's where you met Steven?
Yeah, Steven and I met in a language exchange, I think. Just as friends, inside of it. It was a exchange inside of a cafe and dance studio. Uh,
Nice.
and yeah, and
We're in Medellin.
yeah, Medellin, Calle 10, like the intersection of Calle 10 y Carrera 35, I think. And it's called Valley Spanish if anyone's interested in going there. But
Okay.
anyway, um, we yeah, no, yeah, we met as friends, we talked as friends, and then we're both honestly kind of nerds and pretty passionate about our respective careers and what we do. So eventually the conversations went that way, and I was like, yeah, I need to start doing something again. And he was like, well, I think these things are pretty interesting in my industry. Can we do these things with Python? And I was like, oh, I was like, yeah, I'll help you do this. I was like, let's just hang out for a couple hours and let's see where it goes. And that's when I discovered like all the what I would describe as holes in the industry, like
Okay.
where places just
Okay.
things needed to be, and I was like, who's gonna fix this? I gotta do it,
Somebody has to
So
help you.
yeah, I guess it's like,
Cool. Stephen, you there? How do you recall the first time how like the friendship started where you met?
Yeah, of course. No, he's right. Yeah, we met in the language exchange, both budding students trying to get our heads around the Espanol.
Okay.
Yeah, we went out for a couple of drinks on occasion,
did
and
we?
yeah,
Yeah,
and
maybe.
I really engineer, geologist. Surely there's a union there,
Yeah, right.
and and then I think we had a couple of artisanal beers one evening at your place, and I started drawing on the wall in a texter, didn't I?
Yeah, there was that. No, I remember.
Yeah.
I remember you let me talk.
Mm,
I think you let me talk for an hour about electrical engineering. We had a dinner at a
mm.
Vietnamese restaurant, and I talked to you for like an hour and a half
Oh
about
yeah.
like conductivity or something. I was like, this is
Yeah.
nanotechnology is actually really
And,
interesting if and
mm.
Steven's a scientist, so he just was like, okay, I'll listen to this.
And
Yeah, so
This
Stephen,
is
can
good.
you
And then
tell
we
us?
started going on resistivity, which is the opposite. I go, oh,
yeah.
there's something there. Something.
Uh,
So,
Stephen, can you tell us a little bit about yourself, your profession?
mm. Sure. Okay. All right. I wasn't expecting it to become a focus
No, but you're
on me,
because
mostly
this.
about Andrew. But
Let me give
as
some
I've
context
been
here,
part
Stephen,
of the
because
journey,
let me give you some
yeah.
context here because
Mm,
Andrew is going to talk to us
mm,
about the startup and how
mm,
his friendship with you and the relationship is actually led to the startup. But so I would love to
mm.
hear more about your profession, your subject matter expertise, right, and how that led to the startup.
Yeah.
Okay, yeah, so I'm a petroleum geologist with over 20 years of experience. I've worked in various countries. I've worked in about 12 or 13 basins around the world.
Wow.
I've, I've looked at mostly exploration from various angles. Exploration in oil and gas, those that are in it know there's basically two major pieces of information that we use. One is seismic data, which is a glorified ultrasound, which looks kilometers into the earth, and the other one is wells. And the wells are, to be honest, absolutely critical. The observations and the readings that are taken inside wells are fundamental. How do we interpret rocks? How we interpret rock properties? How we interpret fluids? Is all very integral to how you make decisions in the oil and gas industry. And to give you an idea of how precious they are, any well exploration well in the world will cost anywhere between 10 million and over $100 million per well.
Wow.
Yeah. So depending on whether it's onshore, offshore,
Yeah.
difficult terrains, difficult access, jungle,
Yeah.
deserts. There's a whole array. But what's fundamental and is common to all of those wells, which is something I've grown an expertise in trying to read and understand, is these various tools. And so we're acquiring the sorts of things which lended very well to Andrew and I's discussions, because we started talking about things like resistivity, conductivity, velocity, radioactivity. all these sorts of things are common physical properties, but they're measured routinely in
Cool.
wells.
Yeah.
And
Okay.
a lot of this data is out there. I'm sure maybe Andrew will touch on this. There is
Yes.
volumes of data freely available on open platforms, and if you know enough about it, you can do stuff with it. So,
Cool.
one of the original ideas I had that Andrew and I kicked around, and we did have a bit of success, was we're looking for fracture networks in rocks.
Okay.
So that was one of them. So I'm very interested in trying to pull more out of log data, and that's these various tools that we run down holes. And I think that we've not even scratched the surface. People use very conventional, very sort of cookie cut approaches to look at the responses. But I think if you've got your head tuned in a different way, there are things you can see that others have not. So
Got it.
that's what
Thank you.
drives me and has
Thank
driven
you.
some of the advances.
I appreciate it, Stephen. So that's great. Great for the context that you're giving us, Andrew. So
Yeah.
so you guys met and you realized there is a gap that you could probably fill with of knowledge with tools with Plotly. Can you talk to us a little bit about that?
Yeah, sure. So we'll talk about the genesis and how we came to Plotly. So the first idea was just to create visualization software, and like a lot of people, that we started with what I would say is like the legacy incumbent, which is Matplotlib, right?
Mm,
And so we started with the legacy incumbent, which is Matplotlib. Um, and I felt that it was a lot of work to produce the type of graphs that the geologists wanted to see using that software. And I also understood that I was going to need to enhance whatever software I was working on, because geologists like to see particular graphs and they like unique visualizations that aren't present in every industry, and not every library has those visualizations out the box. So we have to create them.
mhm.
And I when I cracked open Matplotlib to see what it was going to look like contributing to the source of Matplotlib, I thought that was going to be difficult. I felt like I was going to run up to problems there, and so I started looking to see. I just started doing like a competition analysis, looking to see like who else was in the market and who else I could use. And I mean, Plotly basically checked off two boxes that were my prerequisites at that time. One was that they offered a lot of interactive tools, which is 2024, right? We are like, I'm just saying it's like that's modern. We need interactive tools.
Yeah.
We need to be able to zoom in, zoom out, and we need to be able to select and filter data. And so I was like, okay,
Yep.
this is good. And I also I like that it was open source, maintained, professionally maintained software, then that it had a system for accepting open source contributions. And I said, okay, so I can, if I need to make improvements or bug fixes or modifications to the software, I can be reasonably sure that Plotly is going to work with me, and Plotly is going to help me get that stuff done so that I can do my job. And that has been true. So
Cool. So that led to um, you creating these plotly graphs. You realizing, okay, there's something there. There's something promising, and
oh yeah,
that's when you decided to start your business, your startup.
it was a big it was a big actually lift switching to Plotly, because I had already done several weeks of work just using
Okay.
Matplotlib. So I had to excise Matplotlib out of our own package, and I had to get Plotly in. So I just set myself back like a month. As far as the business goes, I knew that the business was always an experiment, right? And it still is an experiment. But it's like, okay, so now we're producing this software that's theoretically valuable to people, and we have to go through this process of seeing who is valuable to, how valuable it is to them, and whether or not people want to sustain it. And
Mhm.
so I decided to incorporate a business around that idea so that I could I wanted to hire a little bit of help so that I could spend some more time doing outreach and marketing, and supervising programming without having to write every line of code myself.
Okay.
And I needed employees for that, and there's laws, so I incorporated the business thinking like, okay, this is an experiment. I don't want to spend too much money, but I want to see if I can get some fire underneath this project. And it's
Yeah.
been working out well.
Cool. Okay.
Yeah.
Um, I know you have some graphs and demos to show us. It
Yeah,
explains a
sure.
little bit to our audience how Plotly comes into play and how what GeoPozo really does.
Okay. I'm going to share my screen. Is that all right? Is this a good time to
Yeah,
do that?
that's a great
Sure,
time.
cool. All right. So now I'm bad at sharing my screen because I always share too many times, but oh, interesting. Share. We'll just see how we do.
Well, once we see it.
Here we
Okay,
go.
it's loading. Okay, we see the whole browser.
Yeah, participants can now see your application and we see the whole browser. I will maximize it. Although I do need
Great.
some of those other tabs if I want to show everything. Right,
Perfect.
so this is a Pozo demo. This is available on Binder. This is also available at github.com/geopozo/pozo-demo. And then you can get all these other links. So this demonstrates the basic parts of the software. There are now two branches of the software. There's the free version, which is what we're demonstrating here, and there is a premium version. I just want to say that the premium version is like we do more stuff automatically. We do more integration with like Google Sheets and Excel sheets, so you don't have to program everything in. And there's also some more science encoded into it. Like we start off with some basic science and we give tools for that science, whereas this focuses a lot on data and visualization, the free version.
Okay.
Outside of Plotly, since geologists have like their whole separate like world of units. They have units that other sciences don't have. They have things called porosity units. They have all the stuff that you don't even find in the international standards. So we have to do a lot of data massaging, and we have to make sure we get everything kind of like we understand what the data file is we're looking at.
Okay.
So what we do is we end up with, from the geologist, we end up with a data file like this. It's actually a human readable list of, these are all columns. So this is the data. This is the list of columns, and this is the actual data underneath the columns. And there's other information about this well, but like I said, these units are not always using standard unit nomenclature. So we have to do a lot of data massaging. And so our software has utilities to do that, where we load the data and then we show you what we think the unit is they're talking about, the confidence level, and it shows you if maybe you need to look to see if the unit is the correct unit, and you can then in a dictionary, you can set it automatically yourself. And then this is like, now we get back into Plotly, right? So data scientists need to they need to do like a basic look at their data. So these are some basic graphs that you can produce with Plotly. You can see the violin plots here at the bottom, and you can see the box plots, which we use for logarithmic data. But this is basically every sensor. This is every sensor that was pulled out of the well. And the whole point of this is to just take a look and see if this data file even makes sense, right? Because sometimes you get bad data and it doesn't even pass the smell test, obviously. So this data is from Australia, and this is a good well file. So this is fine. This is from an open source, like very old well in Australia. So this is just to take a look.
Andrew, quick question. So a graph like this, and we're going to see more graphs, but so does this, from what I understand, this helps geologists understand what's under the ground, better understand their data and their sensors. Does this also, as a result, I'm assuming this also saves them a lot of money. Am I right?
Well, I think so. That's an interesting question. I was thinking about this. So what we do is you could construct all these things by hand, all these graphs and these layouts by hand, just using Plotly, but it would take you hours to do each one, and you would have to manage a large set of templates, and then it would change a lot. So what we try to do is we try to create helper functions that help scientists move through their data faster. And it gets better. We have even better stuff. And what happens is I think we're trying to reduce the cognitive load on the scientists so that they can do more in less time, right? It seems trivial, but when you have to spend 4 or 5 hours just working on code in order to see the visualization you want, you're kind of exhausted, and it sucks, and you're less likely to be productive. So what we want is that people can see, like, do visualization and then do another visualization and do another visualization. So they still have the flexibility of programming, but they don't have all the boilerplate of programming because we're the ones doing that.
And time is money.
Time is money, and people's it's energy too. People just, if it's too complicated to get something done, they just lose energy.
You get stuck in the weeds. If I'm spending 10 hours a day just writing the code, like, okay, what am I seeing here? You just get lost easily.
Yeah. That's not even that. And I believe that firmly, and we can't even really sell that because I don't think a lot of people subscribe. It's 100% true, but I'm not sure how many people subscribe to it. So we also have features, like we have real features that other people just don't have.
Okay.
And, stuff that we can actually say, hey, look at this really cool visualization. You can't get this anywhere else.
Yeah.
So it goes on, and then you can use our functions. We have functions that allow you to customize the graph. So this starts now looking a little bit more like our competitors. So while this is just this graph is every well just next to each other to verify the data. Now we're starting to create a sort of graph that looks more like the sort of visual comparison that a geologist would do in their job, where you have certain lines laid on top of each other. They have certain ranges. And they're in certain columns, as well as we have these notes so that people can identify certain depth ranges and stratigraphies. And we have all the basic features of Plotly's interactivity, so people can move and zoom the graph, right? And they can look at specific areas. And that's one of Plotly's bread and butters, right? It's a really great thing that Plotly has.
Yeah.
We do we have other features where we can start putting in strip logs, and like in the premium features, a lot of this stuff comes from like Excel. It doesn't. So here we see, you can kind of see what we're programming in here is these are intervals, and this is sort of like a spreadsheet programmed in. But in the premium version, you can just use a spreadsheet,
Okay.
and you get these strip logs, which are another visualization tool that geologists use. Yeah. And we just keep on making, this demo just keeps on making small tweaks to the graph to make it, you can see we get the fills in here.
Are these,
This is
as you're scrolling down from up, if I'm looking at the graph correctly, where up and down, just it's depth in the ground?
on one individual graph, yes. So if I zoom all the way out, this is 0 feet into the ground, and this
Okay.
is 1100. This actual graph goes up to 1800 feet into the ground. I think it's feet, not meters. I'm not 100% sure on that. But and these are all just different sensors pulled out of it. And when they were doing this, like Steven said, it's super expensive, so they don't run every sensor throughout the whole range because of the cost of doing that. So they identify ranges that are of interest to them, and then they put more sensors and do more math down in those ranges. So that's why you see that there's data here in this middle section than there is on the very top and the very bottom.
Yep. Cool.
Yeah. So yeah. And then so that's like, this is like our basic, like we need to provide this. This is the basic language of geology. This is what we want people to have access to. Some people are using it just for this. There's a guy using it, I believe in Australia, because their geologists need to be able to browse thousands of data sets. And they just want a way to be able to browse visually those data sets without having to download it, load it into their desktop software, with their big loading times. They can, because we're using Poly, they can just create a web interface.
Okay.
Right.
Now, is geology or welds and drilling, is that pretty much the same everywhere, or you might have a client that might say, you know what, because of the type of well that I'm drilling or the ground and the material, I need a different graph? Does that happen?
Steven is better to answer these questions, but I can say for sure, yes. That's
Yeah,
absolutely, yeah.
Most certainly, yeah. Fit for purpose is certainly a theme.
Okay.
Yeah, fit for purpose, yeah.
Yeah, and depending on
different
the target interval. So the target interval may be a sandstone, but it also might be a limestone. Therefore, you might deploy different tools. That's one example.
Okay.
Yeah.
But I guess, Andrew, what I'm also, thank you, Stephen, for that. I'm also trying to get at is, as you talk to prospective clients, are they like, I'm sure they love what they see. That's why your startup is going very well. But are they like, how many requests do you get of different apps, graphs that you haven't created yet?
Right. Yeah. So that's all of our conversations, because that's what we're really interested in, is finding a niche. As a business owner and as someone driving the startup, it's not super interesting to me to compete with the most basic analysis with the biggest players.
Okay.
Right. There's companies that have been around for 50, 60, 70 years, and they have thousands of people who do basic analysis with their basic software. And I say, like, okay, that's not probably the best place for me to try to enter the market. And that's how we got into getting into like green technologies like hydrogen and geothermal and helium, and moving out of petroleum, because those are underserved industries.
Yeah.
You have all these big players who put all their energy just focusing into petroleum, and it's like, but like, what if we can find other things?
Yeah.
What if this well is useful for other things? So
That's right. Yeah.
Yeah.
Yeah, no, it's good. No,
Right.
I was only going to add on to that. That was why I mentioned fractures earlier in the introduction, because fracture networks are very important for those new types of sciences. So it was one reason we focused the direction, the visualization, yes, but then trying to come up with some clever bits around fracture identification.
It's even such that you'll meet individual scientists who have their individual ideas and workflows. And if you feel that their particular approach to analysis has real value in it, we can build out custom software just to do that particular type of analysis, right? So if you meet somebody who says, I know how to find helium based on this data, I want to automate that across 1,000 wells, we have the flexibility to do that. And larger players would likely just ignore that and ignore that scientist, right? And so it's definitely one of our, it's the flexibility allows us to go after these niches, right? Okay. It's Python. We can build anything we want.
Cool. And where is there any other graph or something you want to show us?
Yeah, so we keep on going. I was hoping to talk a little bit. I don't know how are we with time?
We're good.
Yeah. So this is a cross plot. This is different. You all can see that this is a depth range graph where this is like your y-axis is the depth into the well and your x-axis is the value of the sensor. So you have like the size of the drill hole, you have the gamma ray, which is radioactivity. This is conductivity. This is a measure of porosity, which is a radioactive like hydrogen measurement of some kind. Anyway, then we also have this ability to create crossplots where instead of looking at things against depth, we're looking at particular values against each other. So this is a porosity against density measurement, and porosity and density are measured two different ways. And geologists will generally look at this data and look at how it behaves, and that will tell them a little bit something about the composition of the rocks and what's down there. Because is it going in a straight line or is it all over the place where there are clusters? I mean, they're looking at this data to see if there are certain groups of clusters, what clusters that are in this location, what does that usually mean about the composition of the rock down there, and why is it moving in the direction it's moving? And the awesome thing about, and this is like where we're getting into stuff that we do that's really cool, is you might want to look at, for example, this cross-plot graph, but like within different ranges. And with GeoPozo based on Plotly, it's very easy to do that. It's very easy to say like, okay, like when I zoom out completely, you know, there's too much. This crossplot doesn't mean anything. I think maybe I see some clusters, but like what's really going on? And then you can zoom in and the crossplot automatically changes for the filter and it tells you something about that data. And in this case, it means nothing, right? This data is still all over the place. So that zoom I did, you know, you might learn that there's nothing really special about, I mean, I'm not going to do an actual analysis, but you know, you have to be able to do these types of changes in order to see how the data is changing over depth ranges. And this filter function that we can do with Plotly and this sort of interactivity helps a lot to do that. This is really unique, so we like this a lot. Yeah,
I love this actually. I really like it. It's one of the coolest things we came up with.
Nice.
Yeah, and this is just Plotly JS. We haven't even gotten into this is Plotly Pi and Plotly JS. We haven't even gotten into Dash yet. I was somewhat unsatisfied though, even with this. This is really great, but I felt like I decided doing this just as like a visualization and data scientist that I don't really love colors, because I did a color mapping based on the depth. So
Right.
this is porosity versus density, and I use colors to see what's deeper and what's and you can see if it's more purple, it's deeper, and if it's more yellow. But the thing is we don't have the visual acuity to really see what's going on, because I can't tell the difference between two purples, and I can't tell, and it's not as intuitive to me as geometrical representations of data, because I can't differentiate between two colors. Everybody sees color a little bit differently, so I think you probably lose stuff in translation. And I like colors for really broad strokes. We've all seen stuff like Gapminder where they use colors and mark shape to indicate things, and I think that's great for broad strokes. But once you start getting into this detailed scientific analysis, it's really hard to use color. And so I went and I started working on making videos instead. And so what we do, and this is a little, now Plotly has some built-in animation features, but we built out some animation features that support more graph types. But the disadvantage is that the video themselves, as beautiful as they are, they're not necessarily interactive like Plotly's native animation stuff is. But you can use all the graph types you want. It supports the entire Plotly portfolio. So there's some advantages and disadvantages. And it's awesome. It's great. And we can produce videos. And so I'm just going to show the video now, because I think you can see it if I just open it. I'm going to have to, actually, I think I have it open. Here it is. So we make these videos where what we try to simulate is we have this blue fill here, this blue fill region, which is like the sensor moving down the well. Okay. And it shows the crossplot changing depending on where the sensors are. So the whole blue thing is the range. And I also put on this graph, you can see that there are some annotations, and those are the type of annotations that a geologist might use to determine what type of rock is in that area. Like if the data is following those lines, those are reference lines. So if the data is following the quartz line, it's probably because there's quartz in the well. If the data is following the sandstone line, it might be because there's sandstone. And what we do is we create this animation, and allows us to see how the data is changing over time. And it gives us a little bit more data than just the colors. And you can see that very clearly, because if you come back to this time point and I play it, and I hope everyone can see this while I just zoomed in. Yeah. If you come back to this point and you play it, oh my God, you can see, so can I use my space bar to play it? Yeah, I can. Right there, you see that how it kind of created this loop, right? Yeah. Right at that point, you see this loop jump out. And that's not something that you would necessarily just see from colors, because it's really hard to tell what direction this loop is going in, or if they're related to this. You might just think it's a cluster that's spread out. You can't see that there was actually a moment in time where the loop actually was created in a single direction.
But what does
And if
this
you
loop
look,
mean?
unfortunately, this was not our $2 billion helium find.
Okay.
I wish it had been. But what that loop actually is caused by, if you also look at the graph on the right, you can see that this blue window is passing over this little bump on this black line here. And
Yeah.
that little bump on the black line there means that the well hole, the drill hole, actually caved in a little bit where it is. So that loop there is bad data. So
Oh, okay.
in that case, it's not $1 billion helium find or whatever, but it does show us that not all the data that we have can be trusted, and that's why, and it gives us the whole story behind it, so we have a better understanding of the data we're looking at. Yeah, so you can tell that I'm really passionate. I mean, as much as Stephen likes the interactivity, and I'm with him on that. I also really love, oh my gosh, what is going on? I don't know. I really love the videos, and
Yeah.
yeah, and so then that leads to my work with Botley, working on Kaleido and all that. So
So, for let's jump into, well, before we go into Kaleido, what is, you've developed pretty helpful, from what I hear, graphs and visualizations, videos, some of them unique. What's the next step in the startup? Where are you going
oh,
next?
so we have to do there is some sort of maintenance in, yeah, wow, there's a lot. So startups, there's a lot. We're hiring right now. We're starting a hiring process, so we're trying to get some more help underneath us. And we are, as far as product goes,
Yeah.
The free version is being solidified to an extent. We're just rounding out some features that we promised in the free version and putting all of our energy into the premium version. And in the premium version, so besides like typical business stuff we need, like interacting with Excel spreadsheets and stuff like that, we're really focused on basically doing workshops in the industry and teaching people how to use the software and giving classes on their
Okay.
so that we can help improve our network.
And
We
beyond the
also, yeah.
network, Andrew, are you planning to create other graphs, or you plan to just enhance what you have right now, or are you just happy with what you have? You want to focus on other things?
And so so as far as more product, we have like an actual product roadmap for new graphs we're going to create. It's not always new graphs. Sometimes data comes in different formats, and we need to
Okay.
support other formats. There are other graphs that are useful in geology. I forget what the actual name is. Both of you might know instead of me, but they're the triangle graphs where you have 3 dimensions.
Oh,
Plotly
wow.
actually supports them natively.
Ternary graphs.
Ternary graphs, yes, thank you for that. So yeah, we will be including some native functions for ternary graphs. And our next step, actually, Stephen and I were just talking about this like 2 weeks ago, so I'll just share it. So there is some issue here with deciding what features should be, everyone who's ever worked on open source knows this, what features should be premium and what features should be open source. But I think what we're going to be working on is well correlation. So when people have multiple wells, we need to work on being able to display multiple wells on one graph or on one workspace like this is.
Yeah.
And it's an important part of the analysis. So that is like probably our next major step. That's like, I would say that's like a major release.
Is that you think you'll be using Dash for that, open source, or?
Dash. So where Dash comes in a very interesting place. So Plotly.js, obviously all of our, I keep on saying obviously, but it's not all of our actual product graph, all of our graph features when we're doing visualization stuff, that all comes from Plotly.js, right? Plotly.js is the graphing library. And then where we use Dash mainly, we can use Dash to be able to select between wells because they have that interactivity. We can get drop down boxes and all that. But the reason why Dash is really useful to us is because it helps us deploy our software, GeoPozo and Plotly, into other people's offices in a way that it allows us to spin up servers really quickly, and people can share reports that way. So that's really, I see that integration being where we really use Dash. Obviously, the interactivity is there too.
Right.
Yeah. But
Cool.
it's really about just it's kind of like you need to get your science business ready,
Okay. Yeah.
and
Got it.
Dash is good for that.
Yeah. Now, you did mention, Andrew, that GeoPozo does use Kaleido, and if you worked on Kaleido, have been working on Kaleido, can you share a little bit more about that, please?
Yeah, I've been doing a lot of work with Plotly, collaborating with them on launching a new version of Kaleido. Kaleido is the software that we use to create JPGs, PNGs, and images from Plotly graphs. We needed to come out with a new version, and one of the reasons why I wanted to come out with a new version is because there's a lot of new technologies that we use to make this generation a lot more efficient. And given that I make videos, the more efficient the image generation is, I can make much longer, much more easily. I can make much longer videos, and I can make them much faster.
Yeah.
In the current situation, it still takes 3 or 4 minutes to render a full video, and it always helps to have like a bigger computer. You know, you have more processors, more memory, and if you try to render a gigantic video on a small computer, it's not going to work out that well. But in the new generation of Kaleido, we solve a lot of those problems so that you can do things of any size. Right. So I really wanted to work on that. So Greg from Plotly reached out to me, and I'd already been fixing bugs and doing some work on Kaleido. And he was like, "Hey, can we collaborate on launching a full, basically like a new version, a complete update of the software?" And I said, "Sure, let's go for it." We basically did all that work. We already have a release out.
Okay.
And I'm super excited to use it as the back end for what I've built here with GeoPozo, so that instead of having like, you can see that I have a 50-foot range for this video. I put it right here. The start is at 1125, the end is 1175, and this is running on a small machine right now. But I'm super excited to use the more efficient version of Kaleido so that I can put on like a 500-foot range, and it can render the entire video. It's super detailed. There's a lot of detail in the video, and video is a very computationally expensive thing to create. So especially when you're
Nice.
doing it frame by frame. Yeah.
Cool. Awesome. Well, thank you for working on Kaleido as well. Really appreciate
Yeah.
it. I know it's going to be a helpful new release and update for the community, the Plotly community. Um, Andrew, I want to transition a little bit to the startup life. Everybody knows
Yeah.
having a startup is not easy. What are some of the challenges that you've gone through, and how have you tackled them?
Yeah. So cool. Yeah. When I first started this, a lot of it was programming in the beginning, right? And I was just like trying to get product done. I was just doing, it was months of programming, which is fine. And then you start doing reach out and you start talking to potential clients, and people say don't do it that way. People say you should, find customers before you start product development. I agree. I agree with that. You'll hear that a million times. You're right. If you can do that, do it. But from where I started, I said, I need to come out with a product. I need something to add to my brand. I don't think people are going to really want to talk to me until until I brought something to the table. So I chose to make this software first, and it worked. That strategy did work, but it was expensive in the beginning because I had to spend a long time programming. And then you start talking to people, and you start talking about contracts and stuff like that. And you start talking about expectations, and you start talking about investors. And now you're switching hats all the time, right? And you don't have it's like, if I need 4 or 5 hours uninterrupted time to program, I don't always have that anymore, and I have to really fight for it. And, sometimes it feels like just the anxiety. In the beginning, there's just tons of anxiety because you have all these pressures coming from different places. You have tons of people talking to you. You have outreach, your phone's ringing at whatever time. And plus, you're just trying to focus on solving like a bug. You
Right.
just have like a bug
Yeah.
that's a real head scratcher, and you're trying not to be pulled off from doing that bug. So and then on top of that, if you manage the money in the company wrong, you're done.
Right. Right.
You can't do that. You can't mess that up either. You have to kind of know what you're doing. I So what's the solution for that? I mean, you have to. It it helps to have more people helping you.
Right.
More founders is better. I'm really
Okay.
grateful for having Steven, obviously. It's also really grateful for Plotly because you guys do a lot of open source stuff, and I mean, if it wasn't there, I'd be done. It'd be
Right.
over for me. You
Okay.
know, um, it's helpful to have more help, people who can take the weight off you. You have to maintain your health, and you do have to prioritize it. Try to handle the anxiety of just having pressure coming from every angle, and figure yourself out. For me, it was like, how do I change hats? And I know I need block time to program, so I try to wake up early to do that. I try to get my 4 or 5 hours in the morning. And I know that I have to get exercise, and I know that I have to get sun. And if I don't, it seems trivial, but if I don't really focus on it, it gets easier to burn out. I don't if I, As long as I'm handling like my basics, I don't burn out. I'll be productive all day, and I'll be fine. So it's you got to know yourself. You got to know your own creative processes and your own challenges. You have to deal with those. And then on top of that, you're managing yourself in the business, and then you're managing the finances of the business, and you have to deal with legal issues, and you need, know where you need help and know when to go out. Yeah, it's
Yeah.
a lot.
I like that advice for our users. Like, if people are thinking or if recently begun their own startup, like know yourself, know what your needs are, how to take care of yourself, and dedicate time to yourself so you don't, because you've went through burnout before in your life and you know
Yeah.
how it is. So you're probably, because of that, you're better at recognizing when you're close to being burned out, and you got to take care of yourself.
Well, and in that vein, if you're really new and you don't, I don't know who I'm speaking to and how much business experience they have, but like I said, when I started freelancing, you need to be very careful about what you sign, especially when you're working in software, because when you start making big promises, and it seems like a really good deal and a big contract, I mean, do you really have the experience to determine what it's going to be like for you over the course of that entire contract? If you sign like a 6 month fixed price contract, do you really know like how difficult or how hard those 6 months will be, or where you're going to be in 6 months? And you get the Dunning-Kruger effect, because people who don't have experience with project management uh are probably more likely to sign a bad contract. And if you have experience with project management and you've seen things go sideways, you might say, well, I don't know about, maybe we should take it a little slower. Maybe we should bite off a little bit less first. Like, I think there is a way to get this done, but I don't think that we should set expectations for the next year today. I think we should, take it piece by piece. You might do something like that, but that comes with experience. And if
But
you're
what do
just
you mean,
starting out,
Andrew? What do you mean take it piece by piece? So the advice is don't sign a six month contract. Just do it like a week by week, or month by month.
well, it depends on the contract, right? So if they're talking about a really big project that they want to get done, I think it really comes down to just, you should be skeptical and you should be patient,
Okay.
and you should read over, and you should let yourself sleep on things, and you should think about things, and you don't go into it, too starry eyed. Yeah. Just be patient, and talk to other people about it. If you have more experience in your life, go talk, you don't need to do everything by yourself. And especially if it's just like a contract review, go find a project manager. I mean, seriously, go to anywhere, go to Plotly, contact some project manager on Plotly on their LinkedIn, and just be like, hello, you have a lot of experience. I don't, will
Yeah.
you advise me for, just be my mentor for 30 minutes, and I want to talk to you about a situation. I don't know. Find
Nice.
somebody.
Yeah.
Everybody wants to help. So
Know how to reach out for help. That's great advice.
yeah, definitely reach out for help.
Cool. Andrew, thank you so much. I think we're close to being done. Is there anything else you want to share? Final remarks?
I mean, I hope that the point of the software isn't just to, make money. We also wanted to create open source software that could be used for educational purposes and fill in some gaps in scientific research, right? We need these sciences to advance, especially, if we're going to deal with like the climate change challenges and stuff like that. We need investment in other technologies, and we want to focus a little bit more on people who are working on that and give them access to these tools. Yeah, so that's really important.
Cool. Thank you, Andrew. Appreciate it. All right, everybody, we're gonna call it a day. We're gonna put this video on, well, as you can see, on YouTube, on LinkedIn as well. So hit the like button, share some comments, or questions if you have. Would love to try to answer them, and we'll see you at the next Hangout.